Hello student. Today let's be discuss about the beam and its derivation of the bending moment. At first, what is beam? Beam is a structure of the building which can be bear the loads. So beam can be defined as the a rod or a bar of uniform cross section whose length is very much greater than the thickness. That is called beam. Beam may be several types. So and let's we calculate the its bending moment. First of all, what is bending moment? So when a beam is considered, we apply when beam is considered, we apply a couple subject to which it changes in this way. So then it bend like this way. So there is the elongation in their bending. So that is called bending moment. It is the moment the applied couple subject to which the beam undergoes bending longitudinally. This is called bending moment. So let's we derive an expression for this one bending moment. At first we consider a beam in this way AB, and there is a it consists a number of layers AB, AB, CD and EF, which are very close to each other. When we applied strain, they elongates. When you apply strain here by applying loads, then it bends like this way. So A changes to A dash, B dash, C D is remains CD, where E F is changes to E dash and F dash, and A dash B dash is elongates, whereas E dash and F dash is contract. So then they form a imaginary circle. With the radius r. So that is, and angle is subtended at center theta. This is the angle theta. Then we say that ABCD is equal to AB is equal to CD equal to F, that is equal to R into theta. R is the radius of the subtended circle, and theta. Then it can be considered as a before that is the original length, that is R theta. When we load is applied to this beam, AB elongates, EF contract, where CD remains same, that is called neutral axis. Then R is the, when we apply load, as you know that AB elongates, then R is the A dash B dash elongates with the radius R from the CD. Then length A dash B dash is given by R plus small r into theta. Then the change in length can be calculated, and before we apply and after the strain is applied, then we calculated A dash B dash minus AB. A dash B dash is the R plus R into theta. AB is the R theta. Then we define R theta is R theta get cancelled. R theta is remain change in length. But we know that longitudinal strain, as we strain definition is there, longitudinal change in length to original length. So change in length is R theta, small r theta, and original length is capital R theta. Theta get cancelled. R by R is gives the longitudinal strain. We know the longitudinal strain and original strain. We can be calculate the Young's modulus. Young's modulus is the can be defined as longitudinal stress to longitudinal strain. So then Y is longitudinal stress means force per area, where linear strain is change in linear strain, that is small r by r, then be corrected as Fr by dr, where A is the area and F is the force acting on that beam. So then F is equal to YAR divided by R. But the definition of moment of force can be calculated, force into distance from the axis. Then the moment of force is equal to F, distance is that is R. Then F we already calculated from equation 3rd, we can substitute here and we get the moment of force is F is YAR and R, then gives the Young's modulus YAR square by R. Let it be equation 5. This is for only consider for the only 3 layers adjacent to the neutral axis. After we consider for entire beam, that is algebraic sum of YAR square by R. Some rearrange the terms here. So we get AR square sigma AR square. Here sigma A is the area. Sum of area is that is nothing but their mass. So it gives the moment of inertia. As you know that moment of inertia I is equal to m into r square, the product of mass into the square of their distance between from the axis of rotation. So that is gives the moment of inertia. So I equal to a square, that gives the, putting this value, the bending moment can be calculated as y by r into y, where y is the Young's modulus, r is the radius of bend and I is the moment of inertia. As consider moment of inertia can be depend upon the shape of the beam we use here. So if the shape of the beam is rectangular, then I can be calculated as I BDQ by 12. So this is the standard definition of moment of inertia for the rectangular beam. B is the breadth, D is the thickness. D means thickness here, B is the breadth. So then bending moment for the rectangular beam can be calculated as y by r is common, as like here y by r. I is the BDQ by 12, for the bending moment of a rectangular beam. If the bending moment for the circular beam, so the moment of inertia can be given by I by pi r square by 4 for circular. If the beam is circular, then moment of inertia pi r square by 4, because the moment of inertia changes with their shape. That's why then bending moment can be given by y by r into pi r square by 4 is the bending moment for the circular beam. This is about the bending moment for the rectangular beam and bending moment for the circular beam. In exam it may be ask you what is bending moment of beam. Derive an expression for bending moment, that gives the, this is the expression y by r. But calculate for the rectangular beam and circular beam, you should write these two expression here for the bending moment. I hope you will understand. Thank you very much.